Translating words into symbols. Sometimes when we want to solve word puzzles, it's much easier to put our words into symbols so that we can visualize the comparison between the parts of the whole. Let me give you an example. Suppose I had said 3 of my students own a lot of CDs. Chris owns about 3 times as many CDs as George, but Emma only owns about half as many CDs as George. So how could I put this, the amount of CDs that they have, into symbols? Well, first of all, you need to write the names of the 3 people that you are comparing. We're comparing Chris, George, and Emma. We said that Chris has 3 times as many CDs as George. And then we said Emma only has half as many CDs as George. So it sounds like we're describing both Chris and Emma in terms of how many CDs George has. So let's say that George has X number of CDs. Okay, now we said Chris has 3 times as many CDs as George. So to describe Chris's number of CDs, it's 3 times as many. That would just be 3 times X or 3X. 3 times X is the same thing as writing 3X. Either one of these are just fine. Then we said Emma only has half as many CDs as George. So if we want only half of George's amount, we've got to either take George's amount and divide it by 2, or we could write it like 1/2 times X. Another way of writing 1/2, of course, is 5/10 or 0.5X. So any of these symbols will work to describe how many CDs Emma has translated in terms of the number that George has. Let's do another example. Now let's do another example. Suppose we wanted to compare the number of boys and girls and maybe the total number of students in the classroom. We'll let B represent the number of boys that are in the classroom, and we'll let G represent the number of girls in the classroom, and we'll let T be the total number of students in the classroom. Okay, so suppose that I said in this classroom there are 5 times as many boys as girls in the class. How could I write a rule that describes how the variable B is related to the variable G? Remember, I said there are 5 times as many boys as girls in the classroom. All right, so the number of boys is 5 times the number of girls because there are 5 times as many boys. So in order for these two things to be equal, remember there are more boys than girls. So I would have to multiply 5 times the number of girls to get the number of boys there are. I know that seems a little tricky, so you may want to think about that a little bit longer, kind of mill it over in your mind. Now, what if I wanted to relate the total number of students? The total number of students would be, well, it'd be all the boys and all the girls. So here's how I could write it if I wanted to use both the letters B and G. The total number of students is all the boys plus all the girls. Now this is the trickiest of all. What if I wanted to say, to talk about the total number of students, but only use the letter G? Well, G represents the total number of girls. I'm okay on that, but I can't use a B. But look up here at this sentence. The number of boys was 5 times the number of girls. So 5 times G equals B. So to represent the number of boys, it would be 5 times G, or 5G. Now I'm representing the total number of students. This is our girls, and this is our total number of boys. We just want the total number of students. For our last example, let's suppose 4 friends are running in a race. And let's say that Lisa ran 7 more miles than Tommy. but Kim only ran 2/5 as far as Tommy. Evan ran 3 times as far as Tommy. How could we put this into symbols? We're all describing the amount that the students ran in terms of how far Tommy ran. So let's say he ran X miles. Lisa, we said, ran 7 more miles. It's not 7 times the number of miles, it's 7 more. When you add 7 to something, you call it 7 more. So she ran 7 more miles than Tommy. Kim ran 2/5 as far. When you find 2/5 of something, you multiply 2/5 times that number. So she ran 2/5 as far as Tommy. And Evan ran 3 times as far as Tommy. So this is expressing each of their distances in terms of how far Tommy ran. Now let's make it a little tricky. Let's suppose Mrs. Moore ran 5 times as far as Kim. I didn't say 5 times as far as Tommy, but 5 times Kim's distance. Well, Kim's distance is 2/5 times X. So I need to say 5 times 2/5 X. But when we do that, 5 over 1 times 2 over 5, we notice that the 5's cancel, and we only end up with 2x. Now the question is, who do you think ran the farthest? Well, we really can't tell because we don't know the value of x. But it does look like either Evan or Lisa ran the furthest. And that's how we put words into symbols.